The last piece of our Canon View class is the nested class called CannonThread that extends thread. And this is the class that maintains the game loop and controls when certain other methods get called, such as the methods for updating the positions of all the elements and for drawing those elements on the screen. Now, our CannonThread maintains a reference to the surface holder, which it needs to obtain the canvas, for example, for drawing on the surface view. And it also has this private Boolean variable thread is running, which is currently set to true, and we can set that to true or false by using the set running method that you see defined down here at lines 511 through 514. The constructor for the CannonThread receives the surface holder as an argument and stores it, and then sets the name of the thread, which is a good practice for debugging purposes, because in Eclipse's debugger you can actually see the different threads that are running, and it's easier to identify them by name if you give them a name. So we gave it the name CannonThread, which is of course the name of our class. Now, the key method in this class is the run method, which every thread must have, and the run method controls the game loop. So the first thing we do in the run method is declare a local variable called canvas of type canvas, and we set it to null, and we'll obtain that canvas in a moment. Then at line 521 we get the previous time in milliseconds, previous frame time in milliseconds, by calling system.currentTimeMillis. Now, run, when it first gets called, this will just give a value to previous frame time, because we need to have a current time and a previous time so that there's a differential between the current frame and the previous frame as far as the update positions method is concerned, because every time update positions gets called, it does so based on the difference in time since the last frame was displayed. So we get a time, which is the system's current time in milliseconds, and then we go into this while loop, which is going to keep running as long as this Boolean variable stays true. Then we have a try finally, and the purpose of the finally is so that we can give back the canvas when we're done using it. In the try block, we first obtain the canvas from the surface holder by calling lock canvas. So basically we get the canvas by calling lock canvas, then we use that in a synchronized block here at lines 530 through 538, so that allows us to update the on-screen elements. And when we're done using the canvas, we unlock it by calling surfaceHolder.unlockCanvas and post, and handing the canvas object as an argument. And what this does is it takes everything that we just drew onto the canvas as a result of calls back in that synchronized block, and it posts that onto the surface view. So it basically draws everything onto the screen at that point. Now, in our synchronized block, we lock the surface holder. Then we get, again, the current time in milliseconds, and we calculate the elapsed time, which is the current time minus the previous frame time. Then we add that elapsed time to the total elapsed time, and we do that in the form of seconds. So we divide elapsed time in milliseconds by 1,000. We call update positions with the elapsed time difference, which is the number of milliseconds since the previous frame was displayed. And again, remember that update positions is always going to do that update in a scaled manner based on the number of milliseconds that have gone by since the last frame. So if there's a, say, 15 millisecond delay between frames, then that will be factored in to the scaling of all the elements in terms of where they are on the screen. And then if there's a 25 millisecond delay between the next two frames, then that will result in a slightly larger scaled value for each of the elements being moved on the screen. So this allows us to account for variable frame rates, and it also allows us to account for the fact that not all processors are the same speed. So what you'll find is if you run this game on multiple different devices that have different capabilities in terms of their processors, the game will look and feel the same across those different devices. Now, unfortunately, it doesn't run as well in the AVDs as it does on real devices, and Google is working to improve the performance of AVDs, so at some point in the future it may be the case that it will work just as well on an AVD as it does on a real device. So we update our positions based on the elapsed time in milliseconds. Then we call draw game elements, passing in the canvas that we obtained when we called surfaceHolder.lockCanvas. And then we set previous frame time to the current time so that we store that for the next iteration of the loop. Once we're done with everything in the try block, we execute the finally block, which of course executes regardless of what goes on in the try block. And as long as canvas is not equal to null, we tell the surface holder to unlock and post that canvas, which causes the drawing to appear on the surface view. We then come back around to the top of the loop, and as long as thread is running is still true, we come back in, lock that canvas once again, do the synchronized block once again, which calculates the new elapsed time since the last frame was displayed on the screen, updates everything, draws it all again, etc. So this is our game loop that helps us deal with the fact that you could have a variable frame rate on a given device, and also you can certainly have variable frame rates across different devices as well. And when you're building a game, you want it to have the same feel in terms of speed and performance across all the different devices that you're targeting.